Have you ever pondered the number of habitable planets that exist in our very own galaxy? Welcome to a journey into the cosmos, an exploration of the vastness of our universe, a realm that transcends human comprehension. Our celestial voyage begins here on Earth, tucked away in the backwater of the Milky Way galaxy. The universe, my friends, is a colossal expanse, a seemingly infinite space filled with celestial bodies that dazzle and bewilder. Among these cosmic objects are galaxies, enormous systems of stars, dust and gas bound together by gravity. They are like islands dotting the cosmic ocean, each with their unique character and charm. Our home, the Milky Way, is but one of these myriad galaxies. A barred spiral galaxy, it boasts of hundreds of billions of stars, each potentially hosting its own system of planets. Imagine, if you will, the sheer number of celestial bodies that our galaxy alone houses. It's enough to make one's head spin, isn't it? But what does it mean for a planet to be habitable? In the simplest of terms, a habitable planet is one that can support life as we know it. It must be at just the right distance from its star, not too hot and not too cold to allow for the existence of liquid water. It must have a suitable atmosphere and the right chemical ingredients necessary for life. Our Earth, nestled comfortably in the Sun's habitable zone, is the only known planet to meet these criteria. But as we gaze out into the expanse of stars that light up our night sky, we can't help but wonder, are we alone? Could there be other planets like ours, hidden among the glittering tapestry of the Milky Way? The quest to find these potential other Earths is a fascinating one, a journey that takes us to the very edge of human knowledge and understanding, pushing the boundaries of our technological capabilities. As we stand on our own little planet, we cannot help but wonder how many other habitable planets are out there in the Milky Way. What does it mean for a planet to be habitable? Now, that's a question that has captured the imaginations of scientists and dreamers alike for centuries. It's not as simple as just having solid ground to stand on or an atmosphere to breathe. No, a habitable planet is one that's just right for life as we know it to thrive. Imagine you're making a cup of tea. It can't be too hot or too cold. It needs to be just right. That's the premise of the Goldilocks zone, a term coined by astronomers to describe the habitable zone around a star where the conditions could allow life to exist. Not too hot that water would evaporate away, and not too cold that it would freeze solid, but just right for liquid water to exist, a key ingredient for life as we know it. But the Goldilocks zone is just the beginning. A habitable planet also needs an atmosphere. This thin layer of gases serves a dual purpose. It not only provides the air we breathe, but also protects us from the harsh radiation of space. A habitable planet would need an atmosphere with just the right mix of gases for life to flourish. And let's not forget about the planet's size and mass. A planet too small won't have enough gravitational pull to hold an atmosphere. One too large, and its gravity could create extreme conditions unsuitable for life. So a habitable planet needs to be just the right size, with just enough mass. Then there's the matter of a stable orbit. A habitable planet needs to have a consistent, predictable path around its star, ensuring that the conditions remain steady over long periods. Any dramatic shifts in orbit could lead to drastic changes in climate, possibly making the planet uninhabitable. So, a habitable planet is one that has just the right conditions to support life. From the Goldilocks zone to the right atmospheric conditions, size, mass, and a stable orbit. It's a delicate balance, a cosmic recipe for life. But how do we find these planets? Well, that, my friends, is a tale for another scene. The quest for extraterrestrial life is one of the most exciting endeavors in the field of astronomy. But how do scientists go about searching for life on other planets? The answer lies in a meticulous process that combines advanced technology and complex mathematical models. One of the primary methods scientists use to identify potential habitable planets is by looking for what we call exoplanets. These are planets that orbit stars outside our solar system. To find these exoplanets, they use a technique known as transit photometry. This involves observing the brightness of a star over time. When an exoplanet passes in front of its star, it causes a small temporary dip in the star's brightness. This dip, though minute, can be detected by powerful telescopes. One such mission that made significant contributions to the search for habitable planets was the Kepler mission. Launched by NASA in 2009, the Kepler Space Telescope was specifically designed to survey our region of the Milky Way galaxy to discover Earth-size and smaller planets in or near the habitable zone. The Kepler mission revolutionized our understanding of exoplanets, discovering more than 2,000 of them, some of which are potentially habitable. However, just because a planet is in the habitable zone doesn't necessarily mean it's habitable. A variety of factors come into play, such as the planet's atmosphere, its size and its composition. For instance, a planet might be in the habitable zone, but if it's a gas giant like Jupiter, it's unlikely to support life as we know it. The search for habitable planets is not just about finding any life, but about finding life as we understand it. This is a complex task, as life can take many forms, and we only have one example to go by: life on Earth. The search for habitable planets is a complex and fascinating field of study, and it is continually evolving as our technology advances. As we continue to explore the cosmos and refine our techniques, who knows what we might discover? In the vastness of our galaxy, astronomers have discovered a number of planets that could potentially support life. These celestial bodies, often light years away from us, are not just rocks floating around in space, but potential homes to life as we know it. Let's delve into some of these potential habitable planets. First up is Proxima Centauri b, the closest exoplanet to Earth, located just over 4 light-years away. This planet, situated in the habitable zone of its star, could potentially have liquid water on its surface, a key ingredient for life. Next on our list is Kepler 22b. This planet, located about 600 light-years away, is twice the size of Earth. Although it's larger, it orbits in the habitable zone of its star, making it a potential home for life. Then there's Gliese 667 cc. This planet, located 22 light-years away, receives nearly the same amount of energy from its star as Earth does from the Sun. This suggests it could have a similar climate to our own planet. Last but not least is the fascinating TRAPPIST-1 system. This system, located about 40 light-years away, contains 7 Earth-sized planets. 3 of these planets are in the habitable zone, and all 7 could potentially have liquid water. These planets share similar characteristics that make them potentially habitable. They're all located in the habitable zone of their star, a region where conditions could be just right for liquid water. They're all roughly Earth-sized, meaning their gravity could be similar to Earth's, and they all receive a certain amount of energy from their star, enough to potentially support life. But remember, these are just potential homes. We still have much to learn about these distant worlds. Are they truly habitable? Do they have the right conditions for life? These are questions that await answers. These potential habitable planets give us hope that we are not alone in the universe, but how many more could be out there? Estimating the number of habitable planets in the Milky Way is no easy task. Yet as complex as it may be, scientists have developed a variety of methods to make this estimation. One of the primary methods used is known as the Drake equation. This equation, developed by Frank Drake in the early 1960s, takes into account factors such as the rate of star formation, the fraction of those stars with planetary systems, and the number of planets that could potentially support life. However, the Drake equation has its limitations. Many of its factors are based on educated guesses, and our understanding of these variables continues to evolve as we learn more about the universe. Another method that scientists use is direct observation, mainly through the Kepler Space Telescope. By observing the dimming of a star's light as a planet passes in front of it, scientists can infer the existence of a planet and even estimate its size and distance from the star. But this method also has its challenges. It requires a precise alignment of the star, the planet, and the telescope, which significantly limits the number of planets we can detect this way. Then there's the method of gravitational microlensing, where the gravity of a planet and its star bend and magnify the light from a more distant star behind them. This method has the advantage of being able to detect planets at greater distances from us, but it's a rare event and requires constant monitoring of the sky. Despite these methods, there's a great deal of uncertainty involved in estimating the number of habitable planets. The universe is vast, and our methods of observation are still limited by current technology and understanding. Yet, even with these challenges, scientists are optimistic. They estimate that there could be as many as 40 billion Earth-sized planets orbiting in the habitable zones of sun-like stars and red dwarfs in the Milky Way. So let that sink in for a moment. 40 billion potential homes for life as we know it. Despite the challenges, scientists believe that there could be billions of habitable planets in our galaxy alone. As our technology continues to advance, so too does our ability to explore the cosmos. The future of space exploration is a bright one, filled with the promise of new discoveries and the potential for groundbreaking knowledge. As we stand on the cusp of this exciting frontier, we can look forward to the launch of many ambitious missions aimed at uncovering the secrets of our galaxy. One of these is the James Webb Space Telescope, set to take to the skies in the near future. Its mission? To peer deeper into the universe than ever before, to see the light from the earliest galaxies, and to hunt for signs of life on distant exoplanets. In the coming decades, we'll also see the advent of advanced propulsion technologies, which aim to drastically reduce the time it takes to travel between stars. This could open up new possibilities for exploring those far-off habitable planets we've been dreaming about. Then, there's the exciting prospect of finding life on other planets. As we continue to explore Mars and other celestial bodies within our own solar system, we're developing the tools and techniques needed to detect signs of life, be it microbial or more complex. We're also expecting to see the rise of private space exploration companies, which are set to bring a new level of innovation and competition to the field. This could lead to more affordable space travel, making the concept of space tourism a reality for more people. And let's not forget about the potential for artificial intelligence to revolutionize our exploration efforts. With AI, we could automate the process of scanning the skies for habitable planets, making the search faster and more efficient. The future of space exploration is indeed a thrilling prospect. It's a journey into the unknown, where every discovery brings us one step closer to answering some of the most fundamental questions about our existence. Who knows what exciting discoveries await us in the future as we continue to explore our vast and wondrous universe. The quest to find habitable planets in the Milky Way is a testament to human curiosity and our desire to understand our place in the universe. We've journeyed through the infinite cosmos, delved into the concept of habitable zones, and ignited our quest for extraterrestrial life. We've explored potential habitable planets, ones that could possibly hold the key to life beyond our homeworld. We've estimated, calculated, and hypothesized about the number of these planets within our own galaxy. The magnitude of our universe, paired with our advancements in technology, hints at a future ripe with exploration. Each new discovery, each planet found, takes us one step closer to answering the age-old question, are we alone in the universe? We may not yet know the exact number of habitable planets in our galaxy, but one thing is certain, the search for these planets, and potentially life, continues to be one of the most exciting adventures in science.